History of Time by Stephen Hawking. In a nutshell, Stephen Hawking's groundbreaking book, A Brief History of Time, draws a clear picture of what space and time are, how the general theory of relativity redefined them, and why the universe is expanding. Favorite quote: "Ever since the dawn of civilization, people have not been content to see events as unconnected and inexplicable." Stephen Hawking. Introduction. Humans have always tried to understand the nature of the universe, but few have come as close as Stephen Hawking. Hawking is widely recognized as the most brilliant theoretical physicist of our time for his groundbreaking research in gravitational singularity theorems. Hawking served as a professor of mathematics at the University of Cambridge, as well as the director of research at its Center for Theoretical Cosmology until his death in 2018. In addition to his research, Hawking wrote countless books such as The Universe in a Nutshell and Brief Answers to the Big Questions that brought complex topics to popular audiences. A Brief History of Time explains the nature of space and time, cosmic expansion, and black holes, while questioning the possible beginning and end of the universe. Here are 3 key insights from this book. 1. The general theory of relativity changed the way we conceive of space and time. 2. Hubble's redshift discovery proved that the universe is expanding. 3. Time can most likely only move forward. Insight 1. The general theory of relativity changed the way we conceive of space and time. Space and time not only affect but also are affected by everything that happens in the universe. Stephen Hawking. Suppose that out of a pair of twins, one moves to a mountaintop while the other waits on the ground. At one point in time when they met again, one would be slightly older than the other. On Earth, the age difference would be negligible, but it would become substantial if one twin went on a long journey to space, traveling nearly at the speed of light. The spacefaring twin would be significantly younger than the Earth twin when they returned, a thought experiment known as the twin paradox. The twins paradox, however, only can be called a paradox if you assume that time is absolute. Before Einstein proposed his general theory of relativity in 1915, space and time were believed to be a fixed field in which events occurred, unaffected by what occurred within it. It was natural, therefore, to believe that space and time were infinite. In the general theory of relativity, however, space and time are now considered dynamic quantities. The movement of a body or application of force changes the curvature of spacetime. Similarly, the structure of spacetime affects how a body moves and how forces work. In the theory of relativity, time isn't absolute. Every individual experiences time depending on their particular location and the speed with which they are moving. The previous concept of an indefinitely present static cosmos was replaced by a dynamic and expanding universe that might have a definite beginning and a definite end. Insight 2. Hubble's redshift discovery proved that the universe is expanding. This relationship between wavelength and speed, which is called the Doppler effect, is an everyday experience. Stephen Hawking. When sunlight travels through a prism, it splits up into its component colors of varying wavelengths, making up a rainbow-like spectrum. The distance between one wave crest and the next is called a wavelength. The human eye perceives different colors as varying wavelengths of light. The red end of the spectrum has the longest wavelengths, while the blue end has the shortest wavelengths. The color of light emitted by stars is the only observable property we can use to distinguish between different stars in the sky. Consider a light source that is always the same distance away from us and emits light waves of the same wavelength. The wavelengths we receive will match the wavelengths released. If the source, however, begins to travel away from us, it will have already moved a certain distance away from its initial position by the time the next wave crest is emitted, making the wavelength we receive longer than when the source was stationary. If the light source is a star, it means that the spectra of stars traveling away from us will shift toward the red end of the spectrum. In 1929, American astronomer Edwin Hubble documented the distances between different galaxies and observed their spectra. Hubble found that most galaxies appeared to be shifted toward the red end of the spectrum, which means almost all galaxies are speeding away from us. Even more startling was the fact that the amount of a galaxy's redshift was proportional to its distance from the Earth, meaning that the further a galaxy is from us, the faster it is moving away. The cosmos, therefore, is not static. Instead, it's expanding all the time. Insight 3. Time can most likely only move forward. Despite being a feature in many books and films throughout the years, Hawking believed the concept of traveling back in time to be an unlikely phenomenon. Although time travel could be possible, there are 3 things that we know about time that would need disproving first. Firstly, time moves forward thermodynamically. Entropy is a term used to describe the energy between molecules and how this creates disorder. For example, your coffee mug only stays in mug form because force is holding it together. As soon as you drop it, its entropy will increase as it breaks up into a collection of shards. However, a shattered mug would never spontaneously reassemble on its own. In the absence of an external force, entropy can only increase. Secondly, time only moves forward psychologically. You can never remember the future. For example, after your mug breaks, you can remember what it looked like before, but you can never know the exact position of the shards on the floor before you break it. Thirdly, time only moves forward cosmologically. Starting from the Big Bang, the universe has been expanding, its entropy increasing along the way. Scientists are generally in agreement that the universe is expanding, but the question as to whether it could start contracting is unknown. After reaching its maximum extension, if there is such a thing, it's possible the universe could start reversing entropy and also time. If time were to start reversing, however, we would never be around to see it, as all of the processes that sustain our existence rely on entropy in some form. Wrap up. Stephen Hawking has done more than anyone in history to make the mysteries of the universe comprehensible to the public. But despite his deep understanding of black holes, gravity, and the cosmos, Hawking held that why the universe exists in the first place is the greatest mystery of all.